Okay, so now we're going to be finding the derivatives of the model so that we can look at the rates of acceleration and the rates of growth here, which is going to be our speed of growth. Okay, so we've got this equation here. So I want to be calculating dy over dt for this function, which means that I'm going to be deriving it with respect to time. Which just means that the variable inside there that we're going to be, moving everything around because of is the t variable. So if there was another variable in there apart from y, and we knew that it was standard for just some sort of coefficient, then we would treat it like a number. Okay, so this is what I've got here. Down here would be a good place to insert the rule that we use when we derive these functions. So if you look on that derivative cheat sheet, you'll see it there. But I'm going to jump straight to the answer. So I've got a cos function, so that's going to turn into a minus sine function. The 25 will still be at the front. It's going to be multiplying the derivative of the inside of this bracket. So pi t divided by 11 is like pi divided by 11 times t. So when I derive that, I'm only left with that coefficient at the front. Okay, so sine, this part in here will go straight back in. And that's my derivative. This part here has got no t's to give, which is why he just vanishes. So when I simplify this down, I'll end up with negative 25 pi on 11 sine pi t on 11 dy over dt. Perfect. Now the next thing that we want to do is we want to calculate the acceleration, which means that we want to calculate the second derivative. So I'm going to be deriving this function here for the speed of it, or the velocity. Okay, so again, all I have to do, I take the derivative of the inside of this. So 25 pi on 11 is going to multiply pi on 11. Sine will turn into a cos function, and whatever's in the bracket will go straight back in. So that is going to simplify down to being negative 25 pi squared on 121 cos pi t on 11. So that is the second derivative. That's going to give me the acceleration of the subscribers per month. Or this, yeah. So now we should be ready to enter this into Excel. So I'm going to go over here to my Excel. So by default, Excel is going to be working in radians, so we don't need to worry about conversions. Now when we're inputting our derived functions into Excel, like you can see up here, so I've had to put in for this function here, should have a minus, so it should be minus 25 times pi. So if you try to not put the times between it, Excel will give you an error. Now, when you're using your pi function in Excel, we want to make it so that we're putting in equals pi, double click on the pi symbol, and then just close the bracket. That'll force it to use pi corrective 15 places. It doesn't want you to put anything inside the bracket. That's just how Excel rolls. Okay, so back over here to our code. So then I've put in times sine. Again, now I've put a bracket around it. Pi times the cell that we want divided by 11. I'm going to make sure that has the negative in front of it. Now that this is correct here, I can drag it down to fill in the other cells. So you can see here that they're all negative values, which matches up with what we found in our initial picture. So now we can calculate the second derivative of it. Now I'm going to be inputting this function into Excel. Now it'd be much easier if I take the original one, and I'm just going to copy it, and then I'm going to paste it into this cell here. Now, what is different between these two is pi is squared in this case. This is over 121 opposed to 11, and this is a cos function. So we're just going to adjust our formula over here to reflect those changes. the end of the pi, I'll put a squared there. Put my 2 in there. So now this formula matches the derived one that I've got over here to the side. So I can press enter. Click on this formula, give it a last check that everything's coming through where you want it to. Perfect. Press enter again. Now select the cell, go to the corner, wait till it turns into a little black cross, and then drag that down. So now I have all of the information about where the function is, the speed of the channel's growth, and the acceleration of the channel's growth.